This will be for the con exercise, exponential expressions, word problems, numerical. The number of bacteria in a Petri dish is multiplied by a factor of 1.2 every hour. There were initially 500 bacteria. Which expression gives a number of bacteria after 3 hours? Okay, now I was going to mention whenever you see the expression factor of, that usually means multiplication. Okay, that usually means multiply. But it says right here, multiplied. All right, so it says there were initially 500 bacteria. All right, so we're going to start with 500. And then it is multiplied by a factor of 1.2 every hour. So you take the starting point, the initial value, and you multiply it by 1.2 every hour. So the first hour, it's going to be times 1.2. And then you take that number, whatever it is. You don't have to calculate it. You can just leave it like this. You take this number, and for the second hour, again, it is multiplied by 1.2. And then you take that number, whatever it is. You can just leave this alone. And for the third hour, you can just multiply it by 1.2. Okay, so that expression will give you the bacteria after 3 hours. All right, this value was the initial, or the start. All right, so the 500 was the initial. And this 1.2, that was for the first hour. And this 1.2 was for the second hour. And this 1.2 was for the third hour. So that's it. This is the expression right here. All right, in most cases, you're not going to be adding. Okay, but we can see already it is answer B. Okay, if you want to double check the other answers, this one is adding, so it's not C. This one is adding, this one is adding. This is the only one that matches what I did. Okay, so that is answer B. Moore's law says that the number of transistors in a dense integrated circuit increases by 41% every year. In 1974, a dense integrated circuit was produced with 5,000 transistors. Which expression gives the number of transistors in a dense integrated circuit in 1979? Okay, so this increases by 41% every year. And there's a shortcut to doing that. When you start with 100% of whatever, and you increase it by 41%, so add 41%, that's the equivalent of getting 141% of the initial value. Okay, now to convert the 141 to a decimal, you just move the decimal over 2 places. So that's going to equal 1.41. Okay, and what the 1.41 does is it adds 41%. All right, so you are going to need this in your equation. Now, it says that in 1974, basically you started with 5,000, okay? So this is the initial value. That's the initial value. Let me fix that. Okay, so just like the last problem, let's start with the initial value. That's going to be 5,000. All right, and then the first year, it's going to go up by 41%. So each year. So the first year, it's going to be, let me move this over. I'm not going to have the room. The first year, it's times 1.41. Okay, that adds 41%. Then the second year, whatever this number is, you take that number and you multiply it by 1.41. And then the third year, you take that number, whatever it is, and you multiply it by 1.41. And you keep going. Okay? It said we started in 1974 and we ended in 1979. All right, so that's going to be 5 years. All right, so we have to do the 1.41 5 times. All right, that's for the 4th year. And that's for the 5th year. All right, so the 5,000 was the initial. All right, and this was for the first year, the second year, the third year, the 4th year, and the 5th year. Okay, you started with 5,000 and then it kept increasing by 41% each time, each year. All right, so this is your answer. Now, their answer may be a tiny bit different, so let's look at their answers. Answer A has plus. Mine doesn't have any plus. Okay. Answer B, it's multiplied by the wrong number. Answer C, we start with 5,000, that's correct, and we multiply by 1 plus 0.41, so that's the same as 1.41. And the exponent is 5. That means we multiply it by 1.41 5 times. So that's exactly what I did here. Okay, if you wanted me to rewrite this, this would be the same as 5,000 times 1.41 to the power of 5, because we multiplied 1.41 5 times. Okay, and the 1.41 is the equivalent of 1 plus 0.41. And again, that's still to the 5th power. Okay, so clearly it is answer C that matches my expression. Okay, I would write your expression first and then convert it to whatever form they have it in. But that is clearly answer C. The number of nano-related patents that are granted in the U.S. increases by a factor of 1.2 every year. Increases by a factor of 1.2 every year. In 1991, there were 60 nano-related patents. Which expression gives the number of patents in 1998? Okay, remember we said factor of. When it says factor of, that's going to mean multiply. All right, so in 1991, 60 nano-related, that's going to be your initial or starting value. Okay, so let's start with a 60. And then it's going to multiply by a factor of 1.2 every year. So times 1.2, that's the first year. Take that number, times 1.2, that's the second year, and it just keeps going. Okay, so 60 is the initial. 1.2 is going to be the first year. This 1.2 is going to be the second year. Okay, and it just keeps going. How many years are we going to do? Well, we started in 1991, and we went to 1998. So that's going to be 7 years. All right, so you keep going with the multiplication, and you're going to do the 1.2. You're going to do that 7 times. So first, second, and this is the 7th. 7th year. All right, so if you have 60 and you multiply 1.27 times, that's going to be 60, and the 1.2 is going to be to the 7th power because it's multiplied 7 times. All right, so clearly that is answer B. You can check the other answers just to make sure, but we can clearly see that B is the one that matches. Last one, Fidel has a rare coin worth $5.50. Each decade, the coin's value increases by 10%. Which expression gives the coin's value 6 decades from now? Okay, we are adding 10%, so you start with 100%, and you add 10%. That is going to be 110%. Converting to decimal, if you move it over 2 places, that is going to be 1.10. Okay, so 1.10 adds 10%, basically when you multiply it. Okay, so the 550 is going to be the initial or starting value. Okay, so you start with 550, and then it increases by 10% each decade. Okay, so to add 10%, we're going to multiply by 1.10. Okay, so if you do times 1.10, that's going to be the first decade. If you times 1.10, that's going to be the second decade. Okay, and it keeps going for 6 decades. So you're going to keep doing that 6 times. All right, that's going to be your 6th decade. All right, so we'll have to see what form their answer is in, but this is what it's going to be. Now, I'm pretty sure what they do most of the time, for the part that is in parentheses, they like to add. All right, so if I were to convert this, they like to add and they like to use the exponent. All right, so I'm going to convert this into their type of answers. All right, we always start with the initial value, the 550. But instead of 1.10, they like to do 1 plus 0.10, okay, because that's adding 10%. And since we said we were going to do this 6 times, we said we were going to multiply by that 6 times, we raised that to the 6th power, okay? So you can write it like I did, but then you're going to have to convert your answer to their form, okay? And from the answers, we can see that answer D clearly matches what I have. All right, they wrote 0.1, I wrote 0.10. I like to include the 0 because it's 10%. But at any rate, you can see that answer D matches what we did.